With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello, welcome to Doubtnut. So our question says, in Ellingham diagrams, plots of delta G, that is oxide formation delta G, show positive slopes except for formation of CO, that is carbon monoxide gas, from coke, that is solid carbon. And the question is why, the reason for this particular statement. So let us see how can we solve this question. So here they are talking about Ellingham diagram. So first of all, we have to understand that what is Ellingham diagram. So Ellingham diagrams are particularly used in metallurgy, and why they are used in metallurgy? To determine the stability of metal oxide. To determine stability of metal oxide. And the other rule is to predict the equilibrium temperature, to predict the equilibrium temperature between metal and metal oxide and its oxide and oxygen. So this is the use of Ellingham diagram. It is extensively used in metallurgy. Now here they are talking about the reaction of coke and the formation of carbon monoxide. So the reaction occurs something like this. The reaction that takes place is coke, that is solid carbon, plus oxygen gas gives us carbon monoxide. So to balance this will be 2 here and this will be 2. Now this is balanced. So what we are seeing here is that we are taking 2 mole of carbon and we are taking 1 mole of oxygen, and this one is also gas, and we are getting 2 mole of carbon monoxide. So we only consider the gaseous species. So here oxygen is gaseous species and here carbon monoxide is gaseous species, and we are having 1 mole in the reactant and we are getting 2 mole in the product. So delta Ng is equal to positive here in this case. Now what happens here? This reaction is highly exothermic in nature, so the delta H of this reaction is negative. Delta H is equal to negative for this reaction. That is, it is exothermic reaction. Exothermic reaction. Now what happens? The other parameters we can clearly see that here we were having 1 mole of gaseous substance and here we were having 2 mole of gaseous substance in the product. So the entropy change is positive here, and the entropy change is positive because the moles of gaseous reactant are increasing, and the delta G, that is the Gibbs free energy, delta G, which is equal to delta H minus T del S. So what happens here? As the value of temperature increases, we can see delta H is negative and delta S is positive. So as the value of temperature increases, delta G becomes highly negative. Delta G becomes highly negative, which favors this reaction. That is, on increase of temperature, the Gibbs free energy increases, hence it favors this reaction. It favors this reaction. So what happens in this case? That the slope of the Ellingham graph M, that is slope of graph, becomes negative. So in what happens? In other cases, the O2 gas is consumed to produce solid metal crude, hence entropy becomes negative, except that of carbon monoxide. So in this case, the delta G is negative So we know by the law of thermodynamics that whenever delta G is negative, when delta G is negative, reaction is favorable. Reaction is favorable. But in the case of other gases, what happens? We'll also try to understand that. So in case of other gases, what happens? In other cases, in other metals, what happens? O2 gas, that is oxygen gas, is consumed to produce solid metal oxide. Hence entropy, hence entropy decreases. And by the law of thermodynamics, we know that entropy change in universe should always be positive for a reaction to occur. Negative entropy change is not possible, which shows that such kind of reactions are not possible. Hence what happens that in this case, that in case of carbon monoxide, we get a favorable delta G, that is negative delta G, which favors the formation of carbon monoxide, while in other cases, delta G is positive and delta S is negative, which is not favorable for a reaction to occur. So this was the complete explanation for this question. I hope you have understood all the concept. Thank you for liking this video. Thank you for watching this video on Doubtnut.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.